Hello, I've got another exciting video for you today. This is part 2 of how much space do you need between a fan and a solid panel in front of it to allow the fan to be able to breathe, while also talking about the restrictions that go on around the fan. So let's get right into it. So first, testing explanation. If you watched the part 1, then you can skip ahead. If you didn't, this is the type of testing we're going to be doing. First test is going to be all sides open and only vary the distance between the fan and the solid panel. Test 2 is one side is completely blocked off, or mostly blocked off, I should say, and the air can come in on 1, 2, and 3 sides. And of course, varying the distance from 1, 2, 3 to 4 centimeters from the fan itself. Test 3 is 2 sides blocked. So 1, 2, the air can come in on this side and around the back to feed into the fan with the solid panel in front of it. Again, varying the distance. And test 4 are 3 sides. 1, 2, 3, so the air can only come in from one direction. So a little bit of a visual explanation. So normally the air can just travel directly in. Even with a mesh filter in front of it, it would be traveling in line with the fan. Air can come in and suck in from the sides, but most of the air that's feeding the fan comes directly in. With a solid panel, the air has to flow around it and come in from the sides as well. So it's overall a little bit less efficient. So knowing how far this panel needs to be is going to be important information. And even more than that is if it has extra restriction. So if air effectively can only feed in from one direction, then the air has to make this 90-degree turn and get all the way across to the other side. So there's going to be a vacuum in here while the air is trying to get to the far side of the fan. And realistically, it's going to be hard for the fan to get there. So literally by that, I mean, so we've got the restriction in front of the fan. This is similar to how I would set it up. So imagine that the top is blocked, this back is blocked, and obviously it's sitting on the floor, so let's say the bottom is blocked. So air is trying to flow in, and then how is the air going to get all the way over there? So if this is spaced out far enough from the fan blade, there is enough room for the air to actually be sucked in and then come over to these blades. But if the restriction is substantially closer to the fan, then what you're going to see is that the air won't really make it to the far side of the blade. Again, that side's blocked. The air is going to hit this, and then it will get distributed a little bit as it's, the fan is spinning, so it kind of will spread it out, but it won't, half the fan will be in more or less a vacuum. This video doesn't cover the noise levels. One thing I can tell you from listening with my ears is that when the fan is in a vacuum state, so there isn't enough air to fully utilize the full surface area of the fan, it does get louder because it's struggling to intake air, and it's struggling to get that air to the far side. So this area will be more or less in vacuum. The more space there is, the more like normal sounding it sounds. And actually, if you were to actually have this in a real PC case or anything like that, the panel in front would actually block a little bit of the noise. So now that all that is said, let's take a look at the data. So the findings are similar, but actually a little bit different for 140s versus 120s. 140s has a much larger effect. Like you need a larger distance between a panel and the fans for the fan to be fully utilized, as we can kind of see here. Takeaway from the first section is more spaces to allow the air to travel into it is better, and the further away the panel is, better. Let's take a look at the data from a slightly different perspective. This is open sides airspeed versus RPM. All the tests are open sides, and it just compares it versus distance away. So we pretty much can clearly see how badly open sides at 1 centimeter performs compared to the other tests. And no restrictions is equivalent to 4 centimeters open sides, with only 3 centimeters being slightly off. So you want greater than 1 inch for 140 millimeter class fans. Assuming that all the sides are open around it, which realistically in no case is actually that way. So how about one restricted side? This would actually be the more reasonable like assumption to make, right? 1 to 2 would be the more reasonable assumption that there's going to be some amount of restriction. So at 1 centimeter, pitiful performance. If it's got a very tight front panel, ignore the case, please. If it's at 2 centimeters, so 5 inches, something around those. I'm doing the mental math. I'm not taking out a calculator. It's starting to get reasonable amount of airflow, but you're still losing a significant portion. Once you're at 3 centimeters though, so just over an inch, a little bit over an inch, you're at a really high percentage of no restriction. So that's what you should be shopping for. So 2 restricted sides. Again, this is going to be in a lot of different cases, computer cases that will have this type of restriction. And well, if it's really tight, it's non-functional performance. But as you get more space, you get a lot more of that percentage of the performance that you would get if you were to remove that front panel. And by 4 centimeters, it's equivalent to like no restriction performance. So it just really is driving home the point that a lot of reviewers are trying to make, but no one seems to have data for. And 3 restrictions. So this would be absolutely atrocious. The most restricted airflow. It'd be starving your fans of air in pretty much every circumstance. Mind, at 3 and 4 centimeters, it's better, significantly better than at 1 centimeter, but it's like half the performance of no restrictions. And that means it's harder to cool your case. It's going to run noisier because the fans are going to be running in a vacuum and they're not moving very much air. It's just a no-win scenario. I believe you saw this data from the previous video, but now we're focusing on the right side for the 140 millimeter class fans. I put a calculated restriction on these that it needed to surpass 80%. Otherwise, I just called it 0, just to simplify the data. It doesn't mean that it's actually at 0%. It just means that it didn't reach that 80% restricted data point. So open sides at 1 centimeter wasn't over 80%. You needed to get to 2 centimeters. And then at 50% for one side open, you got 80%, and then the rest didn't reach my threshold for recording the data. At 3 centimeter spacing, we see open sides. Neuron hitting the just stock way of open airflow. Even the one side restricted isn't too far off. Actually, they're perfectly lined up with open sides. 2 sides is still doing okay. It's most of them, especially at 100%, it's at 80%, so it's kind of okay. And at 4 centimeters, well, it's lined up perfectly for open sides. It's lined up perfectly for one side open, and it's close enough for 2 sides restricted. So you need more than 1 inch, especially in, well, the most restricted case is going to be terrible no matter what. But quasi-restricted cases, just don't buy heavily restricted cases, please. Please. General recommendation. All right. And last but not least, this is the raw data. The fan that I used for this testing was the X2GP14. It is the stock fan that comes in the Torrent PC case, so it was the easiest one for me to have at hand. Exact performance data and the percentages we just took a look at may vary from one fan to the next, but the trends of what I talked about should not and would not. And as we saw in these graphs, at higher RPMs, it gets harder and harder. So if you're running a 3000 RPM 140 millimeter class fan in some of these restricted points, it would be pulling an extreme vacuum and would potentially have even like very poor performance results. So all of that said, I do thank you for making it this far in the video. If you like this type of content and want me to do other tests, please leave ideas for what you would like to see. I do have an upcoming video, it may come out before this or after this, don't know, where I did adjustable slot sizes for the intake, where I think that's sort of a equivalent to this, but it looks at it from a different perspective, where instead of blocking off the sides, you block off the straight line inlet and restricting the opening for the air to actually flow in, as opposed to making the air do 90-degree turns. Anyways, I think that one's going to be pretty cool. If you like what I'm doing, please think about joining me on Patreon, becoming a YouTube member. That money goes a long way in helping support this channel. To my Patreon members that have been helping out so far, thank you so much. You guys are awesome. It's helped me acquire a few knickknacks currently. I'm trying to save basically the rest of it to build up for test system and building my test chamber and better microphones and everything like that to revamp how I do testing. Other than that, thank you very much for watching. Have a great day, and I hope to see you next time here on Computer Tech and More.